Thank you. Hey, welcome to our session right after lunch. So it's our job to keep you awake. So Shawn, I guess that's got to be your job, keeping people awake, isn't it?
Yeah.
So would you start introducing yourself, and then I do the second part of the introduction?
Sure.
Sure.
So my name is Shawn Bass. I'm a
Ooh. Whoa.
My name is Shawn Bass. I'm a consultant. I'm based in the Chicago area, and I work for a variety of companies, primarily in financial services markets. And I've been doing Citrix-related products for, well, since the original WinView OS2 product, and pretty much every flavor since then. And I also work with customers that have VMware environments and other vendors as well. So.
Okay, my name is Benny Tritsch, and I'm a technical director at Absence. You will not hear anything about Absence in this session. No worries about that. And in my spare time, I do some protocol comparison stuff together with Shawn, which is really interesting to do because we can work around the clock because he lives in Chicago and I live close to Frankfurt. So that's a 7-hour time difference. Perfect. So he works when I sleep and vice versa. So
yeah,
that's what we do.
It's quite entertaining on this phase of the project because Benny and I each have our own lab equipment. And so I would report some results and I would say, this looks very odd. Can you reproduce on your equipment and see if you get similar results? And so I'd be putting a bunch of stuff into Dropbox, and then he would wake up in the morning, and I'd be just going to bed sending him the status email, and his Dropbox would synchronize, and he'd be like, oh, all this new stuff that you sent. And then he'd do the same thing, and I'd wake up in the morning and have the same results, so it was nice.
Yeah. Okay, let's get started. So what are we going to do today? And you see I present from one of these mobile devices that we will be covering today. And because the focus of our session today will be mobile devices, remoting protocols on mobile devices. And first of all, we give you a short introduction into the remoting protocol, well, fundamentals, just for you to understand what we will be doing. And then we look into the mobile devices that we are testing, which mobile devices are we using, and what is the test methodology, and why are we doing all that stuff. And it's the phase 3 of the protocol comparison stuff that we're doing. And we will give you a short summary about the phase 2 results that we were collecting like 12 to 6 months ago, and before we started the new phase. And the new phase is a very clear, well, next step, because what we figured when we did the phase 2 stuff is that we have to look at specific, well, specific, what can you call it? Not features, but
I think use cases.
Use cases, exactly. Specific use cases that you can use. And so we figured that mobile devices is something that is very popular right now, and so we're looking at that. And this is what we will show you when we present the phase 3 results. This will be the majority part of this presentation. And then we can have a conversation about the results that we're seeing. So
some perspective to this is the third generation, or the third time we've done this over the last 2 or 3 years. And in the phase 1 and phase 2 results, to date, we had collected roughly 600 videos that we're using in the analysis of how these protocols compare on LAN, WAN, various types of networking condition scenarios. And for phase 3, we reported a grand total of 400 new videos that we're using in our analysis. And
yep.
We're sort of selecting the ones that we think are the most dramatic or most impactful, that we think are interesting to see. And we typically don't show you guys things that aren't interesting. So we're not going to cover a lot of things that, LAN-based technologies, because if one protocol uses 80 megabits a second and one uses 512 kilobits per second, but they look, basically the same, it's not so interesting. So we try to focus on things that are really dramatic impact.
It's not so interesting for this session. Tomorrow I will have another session that's about RemoteFX. So using the same methodology, then I'm going to look at the bandwidth that is required for the different protocols. So this starts being interesting at that session. But at this session here, we are not looking at the bandwidth. We are just looking at what is the user experience. OK, let's get started. So comparing the remoting protocols when used on, well, on 3G and 4G. And 4G is not very popular over here in Europe so far, but it starts getting very popular in the US. So maybe you can just shed some light on that.
Yeah, so the reason why we went off and we decided to do 3G and 4G networks is in our phase phase 1 and phase 2 results, some of the vendors, I'm not going to name which vendors, felt that we were being impartial by using WAN emulation technology that's not real world, and it's not fair to our protocol, and it does better for these guys and not for us. And so we decided that, when looking at mobility, why are we going to use a WAN emulator when people who are using these devices are really going to be going over the public internet? So we kind of decided that, well, we're going to take the approach of 3G, 4G networks with these mobile devices and use real-world internet connections. Now, in full disclosure, I have to say that unlike the WAN emulation we did in phase 1 and phase 2, it is impossible for us to guarantee that each protocol had exact equal opportunity from a bandwidth and latency perspective. So these are real-world results, but there's no way that we can say, when we show you a PCoIP video versus an HDX video, these two things had the exact same latency and packet loss and bandwidth, because it's public internet over mobile networks. So what we did do, though, is we took most of the videos, recorded them multiple times, and if we had something that looked completely erroneous, we threw it out and took the better looking video of those. But in most cases, they were actually quite similar between the recorded results. There wasn't a huge deviation.
Sometimes there was an interesting situation, as Shawn said earlier, that we were working in 2 different labs. And sometimes when Shawn saw some results that looked odd, he would say, hey, can you just check out if that looks similar in your environment? And every now and then I did that, and if it looks similar. And we had the situation where Shawn even came over to Germany and did some, redid some tests in my lab. This is what we did like a year and a half ago for one of the tests that we did. And it looked like something went wrong in his lab, but it turned out that it didn't, because it was reproducible in my lab. And this is what I learned when I was still in research. Only if you can reproduce it in another lab, it's an accurate result. And this is what we're doing.
We also were doing last-minute pre-production in the hotel for Synergy Europe 2 years ago. I think it was 2 years ago.
Yeah.
We were actually in the hotel room with like a whole bunch of white box servers set up in the hotel room, 85 power ports plugged in, and recreating last-minute results just to confirm a third time that what we had was accurate.
That's the first time when they asked me, do you need a second key card for your room? I said yes, because I had to make sure that power stays on in the room when I'm not in the room, because of all the servers and the tests that were running in the background. So that was really interesting at that time. So we took some pictures about our data center in a hotel room. Good. Now let's talk about the remoting protocol principles. And there's a fundamental difference between client-side rendering and host-side rendering. And just to give you an impression what we're talking about when we're talking about the client-side and the server-side or the host-side rendering, we created some animations around that. So what it means is that you are doing something on the client. You're clicking an element of the user interface. And what happens then, that click goes to the host. And on the host, there runs the VM or the session, depending on what technology you're using to remote into a session or a full desktop. And what happens then, the results of the click are rendered, are generated on the sender side, on the host side. So basically, the user interface is generated. Now, instead of taking a screenshot and sending the screenshot down the wire, you're taking the individual elements of the user interface. Like in the past, it was GDI calls or any element that you can think of, and you send these elements, the description of the elements, from the host to the client. And on the client side, the real rendering is happening. So you just sent the instruction, paint a line, or draw a rectangle, or do something on that level. And all the real painting happens on the client side. So this is what we call client-side rendering. This has some pros and some cons. And this is something that Shawn wants to elaborate on.
I'll jump into this. And when we talk about client-side rendering, we're really talking about hybrid rendering, because whether it renders client-side or host-side is going to be dependent on a number of factors. So I've outlined a couple of things here. On the pro side, if you're offloading some rendering to the client for either multimedia video or flash content or whatever the case may be, you can greatly reduce your host-side CPU impacts. We've got a chart a little bit later we'll show you what happens when you do MMR redirection versus when you do host-side rendering of video in terms of the host-side CPU. So the pro of client-side rendering is you can offload a lot of that CPU from the host, where it might be very expensive in the data center, off to the client, where it might be very cheap to have host-side CPU resource. Redirected media typically works well in a constrained network. You have minimal AV sync issues because now the client media is actually being rendered locally, so you don't have to worry about audio-visual synchronization so much. It's typically a lower bandwidth profile versus host-side rendering, but this is actually changing very recently as people improve their host-side rendering protocols. This is almost becoming negligible at this point. From some of the cons on client-side rendering is the breadth of features can be very, very dependent on the client-side OS. So what Benny mentioned earlier about you can send an API call to the client to paint a line or put a letter A on the screen, that's going to be dependent on whether the client knows how to actually invoke that API call. So when we're dealing with Windows client machines and Windows host machines, you can do full-blown GDI primitive rendering on the client side. This is very, very thin on the wire and performs very well. When the device is not Windows, it doesn't know how to use Windows API calls. And you can talk about wine and all these kinds of things on Linux, but generally speaking, you can't do any native Windows API calls. So in that circumstance, you fall back to host-side rendering. You get bitmap graphics that are taken on the host and sent down to the client. Some forms of media may also fall back to server-side rendering. So if you don't have the necessary codecs on the client machine to decode the video stream, or if you don't have the right media player, or whatever the case may be, if that negotiation process fails, it goes back to host-side rendering. I talked about the codecs already. Client media may require some buffering time. So when you do host-side video rendering and you click the play button, it immediately starts playing back. When you do client-side rendering, you have to allow some buffering time so you don't have stuttering in the video. So when you do a client-side rendered video playback, you may hit play 5 seconds or 10 seconds later, the video begins to play. So that could impact user experience. You also can increase your client-side resource requirements, primarily CPU, which maybe this is not a problem. If you have old-style PCs that are under 1 gigahertz that you've had around for 5 or 6 years, this might be a problem. If you have 3 gigahertz PCs, dual-core, quad-core, client-side CPU is cheap. You don't have to worry about that. And the last one a lot of people don't talk about is you can really introduce some security vulnerabilities by doing client-side redirection. So in the data center where you might have a lot of control over versions of Flash and you're patching the software and keeping it up to date, if the client-side device has vulnerable versions of Flash and you're doing client-side redirection, you can take a server-delivered URL or Flash object, send it down to the client, and compromise the client machine through the host infrastructure. So this is something you have to be very careful about and make sure that you have ways of making sure people are keeping their software up to date.
And I have an animation that shows you what it means if client-side rendering falls back to host-side rendering, to what Brian called screen scraping in the past, and Microsoft didn't like that term because it refers to scraping pixels from the screen after they were rendered on the server side and then send the entire picture over the network. And well, this is very simple. Some of the elements some of the primitives may still be sent to the client for rendering, while others are rendered on the server side, and then it requires a lot more bandwidth to send it over to the client. And that was the case in the past, that it really generated a lot of more network bandwidth. So for a long time, we thought there's no way to circumvent that, and that the way of the future to do very efficient rendering would be client-side rendering. This is why Citrix, for example, they invested heavily into client-side rendering technologies. And in the past, Microsoft did the same as long as they were using RDP. So that was a lot of client-side rendering involved. And obviously, they came to a limit just because of all the, the cons that you just saw, that it's really hard to make to create the same user experience across different platforms. And now talking about mobile devices, that is very clearly something that you will be seeing later.
Well, let's be honest, if we went back in history 10 or 15 years, it was pretty much a Microsoft world, no matter where you were. There was no client-side devices that were Mac and Linux and all these kinds of things. So the reality has slightly changed, that if Microsoft wants to be able to offer a Windows experience that's best of quality to any kind of remote device, be it a Mac, Linux, whatever, they have to move to host-side rendering, which is what they're doing now with RemoteFX.
And that's exactly what we're calling advanced host-side rendering. So you're doing what was called screen scraping in the past, but you do it in a much more efficient way by using specific hardware like GPUs that help you to do all the rendering, the capturing, the compression, the encryption on the server side. Basically, it's generating a video, an interactive video that's being sent down the wire. So it's only one pipe that goes to the client, And it doesn't matter what sort of client it is, as long as the receiver software, the video player software is installed on the client side. So when I say receiver, I'm not referring to the Citrix receiver. It's more a general term that I'm using here. So there was a question.
This is in a VDI environment, not in the terminal service.
The question was if it's VDI or terminal server. It's in both. To be very clear, there's no big difference between the two anymore.
And to add to what Benny's talking about here, it's not just the advances of the hardware and doing GPUs and virtual GPUs and soft GPUs and all these kinds of things. Even in the absence of hardware, the progression of video codecs like H.264 have made the host-side rendering and conversion or re-encoding in H.264 now applicable to a wide variety of client devices, because almost every mobile device, be it iOS, Android, whatever, is capable of doing some hardware-assisted H.264 decode. So if you put that content into a format that any client-side device can do, even with a low-powered ARM processor, it opens up the number of possibilities for host-side encoding.
Yeah, it's a lot of math that's in there, a lot of algorithms that only came up the last 5 years or so. Yeah, they improved dramatically. Good. Here are the pros and the cons.
So on the host-side rendering side, to say for the most part, it's client OS independent, and I put the word generally next to that. And the reason why I put the word generally is, while it is true that a host-side rendering eliminates the client-side codecs and the media players and all these kinds of things, what it doesn't eliminate is the fact that the client-side device still has to decode some kind of a remoting protocol video stream. So if the client-side device is very low power and it doesn't have any kind of hardware assist, it may be a better experience than it would have been for any kind of hybrid or client-side rendering, but it's still not going to be the best possible experience that you'd have if you had more available CPU or more available hardware assist to help in the encode and decode process. So generally it's OS independent, it's generally client hardware independent. It will work somewhat the same way on iOS and Android as it does on Windows. And that really nice thing is any form of mixed media content can be rendered. One of the weaknesses of the client-side MMR redirection of Windows Media is it was typically limited to Windows Media video types. It wouldn't support QuickTime, it wouldn't support Silverlight, it didn't support Flash. So it was very challenging as these new video codecs and player types evolved that the client-side redirection technology didn't keep up with those changes.
And it looked very weird because sometimes the video started playing back while all the rest of the window was still being rendered. So it took a while until you were seeing all the other elements in order to interact with the video while the video was still playing, already playing.
Also, multimedia content playback begins immediately. So as I said, on the host side rendering, you click play and it starts playing immediately. There's no buffering time required. Fairly low client-side resource requirements. So most of the remoting protocols that do host-side encode can get by with very, very low client-side requirements. 500 megahertz, 700 megahertz ARM processors is absolutely fine. And it will function regardless of client-side AD codecs. Again, if the client-side device has H.264 decode capability, then your host-side encoding engines can take advantage of hardware decode and make it an even better experience. But not all the protocols use that. On the cons, you can have a very high host-side CPU impact. If somebody plays back an HD WMV file or a HD flash or Silverlight or something like that, you're going to have a high CPU spike on your VDI or terminal server environment. And there's not a lot you can do for that. There are some vendors like Teradici that have an offload card that are doing processor-based encode of the video stream to offload some of that, but it's still a challenge. You can have some AV sync issues in constrained networks, but generally speaking, the host-side rendering will do a better job than the client-side rendering in constrained networks. And then it's typically a higher bandwidth profile versus a client or hybrid approach, but this really depends, and we'll cover some use cases where it's different.
Yep. And typically, you will not see 100% host-side rendering solution out there. As soon as it comes to really rich multimedia, in that moment, all the protocols are trying to redirect, or most protocols are trying to redirect videos, for example, if they find the codec on the client side, because that's more efficient. So yeah, it happens during the connection between the client and the server, that there's a handshake, and this sort of information is exchanged between the server and the client. So the server knows exactly what the capabilities are on the client side and sends down the data accordingly to that. So it's smart enough. The protocols are smart enough to adapt. Good. Now, let's look into how we did it and what we did. So we basically compared the 5 protocols here. You see RDP and RDP 7.1 RemoteFX is not covered in this session here. As I said, that's going to be in the session tomorrow, where we're going to dig into that. But we're looking at Citrix, we're looking at VMware Teradici, PC over IP, Quest AOP, and Ericom Blaze. We were also looking at other protocols in the past, but this is not covered in this session here.
Go back for 1 second.
Okay.
Are people in this room very interested in these other protocols that are up here? We've done RGS in the past. That was in phase 1. We have not done SPICE or ALP or AIP. Are these protocols things that you guys are interested
Anybody using those?
Okay, I guess we're making the right choices.
One.
RGS, yeah. So
yeah.
RGS we did cover in the past, and we sort of put RGS in the bucket of sort of the high-end graphics workstations. So we covered it in the solutions that used a GPU for host-side, CAD/CAM 3D software.
And a one-to-one connection.
Yeah, it does require host hardware.
Yeah. Good. For the tests for phase 2, we were using the Apposite box as a WAN emulator. This is what Shawn said earlier, that we're using this dedicated hardware. It's an appliance that allows us to recreate the same network conditions again and again in terms of network bandwidth, latency, packet drops, and all that stuff. And it also allows us to look into what bandwidth was required during the test. So it tracks everything, and you just can make snapshots. You will see some of these snapshots later. And the other device that we're using is an Epiphone DVI to USB box, which is used in pretty much the same way as I'm using the projector now. So you just connect the HDMI or DVI output to this box. And what it does, it converts the signal that comes out of the DVI output into a USB signal in pretty much the same way as a video camera does. Now you take this signal, this USB signal, and you feed it into another PC that you use as a recording device. It records the video. And this is exactly the setup that we have here, the PC with the Epiphone recording software. And this allows us to do everything on the client and use all different kinds of clients without installing any local software on the client. Because as soon as we start installing something on the client, we modify the result. So we modify, well, the user experience, we change it. And that's also something that we learn. Never change, modify the test setup in a way that it has big influence on the results.
We did some early results with Fraps, like early on in this project we were preparing we were using Fraps initially, but Fraps would limit us to Windows endpoints and possibly Linux, but it impacts the client-side CPU in a pretty big way. So we decided we're going to take it out of the client-side device and just pull the frames right off the DVI cable.
And the setup for phase 3 was pretty much the same, except for the WAN emulation. So as Shawn said, here we were using the real mobile network and not something that was emulated.
And these were all done from the exact same site. It's not like we did one, over in Chicago. We did the next one over in Barcelona. It was the same host hardware, same client hardware, same exact 3G, 4G internet connection. So there's no deviation in hardware.
Even using the same hard disks. That was a funny thing when I went and bought a couple of these hard disks because I went to a shop and said, I want to have 4 500 gig hard disks. And the guy said, well, don't you know that we have 2 terabyte hard disks? You can buy one, and it's cheaper. I said, no, I want to have 4 500 gig. And he said, why? Yeah, doing tests, and they need to be identical. So I need to buy stacks of them, and you did the same.
Yeah, I've got like 10 hard drives. They're all identical Hitachi HDX 500 drives, and we put them on hot swap SATA base, so we can just pop them in and out of the host hardware and switch configurations without having to rebuild anything. So this is how we do the tests running. Starting it from the client, when the client is connected to the host where the session or the VM is running. We are running scripted tests there using Autoit to make sure that it's reproducible. And then sitting in front of this device and recording it with the Epiphone. So you see this little Benny here and doing that over and over and over again. Yeah. Because you need to click simultaneously to start the test script and the recording. So for hours and hours, you're sitting there in your lab and you're double clicking, meaning 2 fingers
2 return keys, and off we go. And we're doing that for hours. So sometimes my wife comes down into my lab and looks at what I'm doing. Oh, watching videos again. I say, yeah, sort of. But she said, it's the same video again and again. Don't you get it?
So you're playing whack-a-mole again.
Yeah. We will see that later with the different tests. Because the question was, what tests are we going to use? So we have tests that are focusing on text, like the good old GDI stuff with WordPad and with Acrobat Reader. So these are 2 of the tests that we're doing, 2D graphics and text tests. And then we have videos and animations like Media Player, QuickTime, HD Video. We have Flash, we have Silverlight. And then we have 3D graphics. And we cannot use the 3D graphics too much on the setup that we have here. So only the WPF is something that we're using, none of the others, because they don't really work on the mobile devices. Soft emulation. But well, you will see that it's not really the use case for mobile devices to do high-end 3D CAD. And the other thing is we have some test applications where we try to check out what the user experience is. In particular, whack-a-mole is a new hobby that Shawn has, playing whack-a-mole in his lab, and you will see the videos later. He's really doing well, so I'm not trying to compete with him. So he's doing all the whack-a-mole demos.
So let me explain really quickly why I think whack-a-mole. It wasn't because I love the game or anything like that.
No,
do you guys
I thought it.
In the UK or throughout Europe, is this like, you know what this is? You know, it's a little carnival game. You hit the thing with the hammer. So the reason why we did this test originally is before we did the mobile platform, we were doing Windows desktop PCs with a keyboard and a mouse. And the problem was the majority of the tests that we ran in the past were click a key, run some server-side script where a bunch of media comes down to you, but you don't interact with it. And we thought, well, that's kind of one-sided because the user experience has to be reactive to what the user's actually doing. It's not just about cramming content down. The person might want to pause the video or maximize it or something like that. So we thought to ourselves, what kind of a scenario could we create that would measure the entire feedback response loop of let some content appear in my display, let it fully render, let me acknowledge it by tracking the mouse, clicking, send the server-side click of the mouse, have the server acknowledge that, retransmit the change down to me, and then complete the reaction cycle again and again and again. And so what we thought is, a stupid Flash-based video game is a great scenario like that, and I don't advocate that your users play Flash games, but they probably are. So we decided this would be a great scenario because if there is degradation of the user experience for the whack-a-mole, what will happen is you'll go to track the mouse to click on the mole, and he's already gone by the time the server-side rendered application has caught up to it, and then you miss the click, and you move to the next one, you kind of miss it there. So we figured that would be a great use case for measuring that whole feedback experience.
Well, actually, that was a very educated explanation for his addiction that he has to that game. So now he has a good reason why he can play that day in, day out. Okay. What have we done with the raw videos that we recorded? Because we recorded them at the full resolution of the screen, typically at the standard VGA resolution. And we rendered it down to a smaller size that is only half the size. And we made sure that it's a fixed bit rate, because we want to compare these videos side by side, and we want to make sure that not one plays back faster than the other because it requires more bandwidth or more data volume. And this is why it was re-rendered, and this is what we're using, and putting it into a 4-up Silverlight player. We decided to use Silverlight because it both runs on the PC, under Windows, and it runs on a Mac. And Shawn is using Macs, and I'm using the PCs. So we want to make sure that we can both demonstrate these videos on our preferred machines. And Silverlight does the job better than Flash does. That was surprising. So we're using Silverlight for that, even though that we know that Silverlight will not have a great future. Huh? Yeah, we know, so we need to come up with something new. But now we have our own Silverlight player. In the past, I had to compile each of those 4-ups individually and create an individual application, Silverlight application. Now we have a generic Silverlight player, which you will see in a little bit. And we have a configuration tool that you can use to just set that up. And then you can put the 4, well, head to head. You will see many of these videos in a bit. OK. let's jump into the phase 2 results. OK, so the first 4-up split screens. You want to explain those?
Sure. So we are working here with software-based protocols, so there's no hardware GPUs in the host-side systems. This is what you typically get for a virtual desktop infrastructure. So we're not doing host-side hardware in a one-to-one. This is a VM running on a hypervisor. You're connecting with the remoting protocol. And keep in mind, the host hardware is the same exact Core i7 white box server running one of these hypervisors. So we're using Zen Server 6 for the Zen Desktop 5.5 infrastructure, vSphere 5 for View 5. We're using Hyper-V for the 2008 R2 Hyper-V for vWorkspace, and we're also using Hyper-V for the Ericon Blaze. So when we have these systems running, we have basically the same number of VMs running on the host hardware. We have the same exact host hardware being used. The reason why we have to use different hypervisors is frankly because VMware won't run on any other hypervisor, so we have to do it on View. And so we put as many things as we could on Hyper-V, but we figured it might be a good idea to have Citrix on their Zen desktop product, and that would allow us to do things like GPU pass-through tests at a later date and things like that.
Now let's take a look at how this really looks like. So we have that first setup. Let's start that.
So this is
that's our little server-like player.
Phase 2. This is
phase
a
2
megabit WAN connection that's emulated with 200 milliseconds of latency. And what you're seeing is that all 4 of these remoting protocols, even over what's sort of an extreme WAN condition, they all perform pretty much identically. There's really no user experience difference that you can easily perceive for a simple GDI and bitmap application like Acrobat Reader. They all perform remarkably well.
And now you understand what I'm saying when I'm tweeting, I'm dreaming in 4-up split screen videos, because after creating like 200 or 300 of these videos and just watching them all and seeing what can you see and making selections for these presentations, you start dreaming in 4-ups, which is interesting because you see many more things after a while.
I think the key thing to keep in mind on this is, there's a lot of people out there in the industry. Brian's talked about this before, and other people have been tweeting about this, that the remoting protocol war is over. And I could not disagree with that more.
Yeah.
I think the remoting protocols are getting to the point where if you're an information worker, task worker, knowledge worker, you're doing basic 2D WinForms applications and GDI applications, that kind of stuff, then yeah, the protocols are all pretty much the same at this stage. However, when you start getting into any kind of media content, Flash, Shockwave, Silverlight, doing WPF applications, or if you're taking these things over various types of mobile devices like an iOS iPad or an Android tablet, now the discrepancies between the protocols really start to show themselves.
Absolutely.
That's why we focused on that in this phase.
Yeah, Shawn and I and Brian, we had this conversation before because Brian made this statement a week ago at Synergy that the protocol war is over. And that was one of the statements that he made I completely disagreed with. And so we have to really point out it just started, because it's a lot of math that's behind it, as I said before. And so I'm really looking forward to see the future results there. Okay.
Over time, more and more things are going to change or make this more interesting, like NVIDIA's VGX announcement that just came out last week. Oh yeah. That changes everything. Yeah. And all of the different vendors that have their own unique positive spins of what they can do, the playing field has been leveled now.
Also on the client side, I mean, I'm waiting for the time when you go to a shop and you buy a TV, and it comes with all the remoting protocol decoder chips in the box, so that you see a new label on your TV. RemoteFX enabled, HDX enabled, PCoIP enabled, you name it, because all the new protocol versions, they are tuned to be decoded in hardware. And so that makes it really interesting. So the next thing is that we have is putting Zen Desktop and View head to head. So up here you see the Citrix side, and down there you see the VMware side.
And the reason why we did this one is we prepared these results sometime around between like May and July of last year. And that was when Citrix had sort of come out with Zen Desktop 5.5 and VMware came out with View 5. And Zen Desktop 5.5 had some protocol improvements in it, but View 5 was a massive release for VMware in terms of remoting protocol, really, really improving the remoting protocol. So what we wanted to do is say, what would it be like if we put View 4.6 against View 5 and Zen Desktop 5 against Zen Desktop 5.5 and look at some results. So that's what we did.
Okay, let's take a look at the results. So what you see here is I'm really trying to use Windows 8 as my standard platform and only using touchscreen and the like. It's really interesting. It's a challenge. Okay, next time. Huh?
Benny, it's a challenge or it's a pleasure?
Well, at the beginning it was a real challenge. Now I'm getting used to it, so I find those places where to touch well, the screen and everything. So it turns to be a pleasure more and more. But at the beginning, I was like, holy shit, what can I do here? So I'm really going the hard way. Okay.
So this video here is a HD WMV video that we're running. We're running now in this case over a 6 megabit, 200 millisecond link. And what you end up noticing here is that View 5 does a much better job rendering this content. These are both host-side content. Up here we have client-side rendering, but what's really striking about this is XenDesktop 5. This is XenDesktop 5.5. They actually went backwards in terms of the user experience. And the reason for this is that Citrix introduced in XenDesktop 5.5 something called frame dropping. So what they'll do is if they determine that the WAN link is not capable of rendering all the frames that are in that video, they will drop frames in between keyframes of the video file. The problem is if the video you're watching doesn't have keyframes every half second or something like that, you could lose a lot of content in between keyframes. So that's what you're seeing here on the XenDesktop 5.5 video. It's actually a worse experience than it was under XenDesktop 5, where they were just pushing down as much as they can, as fast as they could, and the client was, not keeping up. So
yeah,
better experience there. What you find is that View provides a pretty good experience, but it stutters quite a bit on 4.6. With the improvements they made, the key difference between these two sets of videos, this is the the non-build to lossless with a lossless method that View 4.6 used. Here we have disabled build to lossless, and we're actually using their compression that VMware added into View 5, to where we have a smaller bandwidth profile and it's more responsive, but we're not using the fully lossless model that used to be the only option really that you had in View 4.6. So here we've disabled build to lossless, and we've also set an audio cap at 100 kilobits. As far as the HDX stuff, we pretty much use out-of-box defaults. We just enable flash redirection and multimedia redirection, all these kinds of things in policy. We do have documented all the settings that we use, and at some point in time we'll figure out a way that we can share all of that. Just putting all the details in these slides is very challenging, but they're fairly out-of-the-box configurations, minor tweaks.
Okay, so now looking at the results from a network bandwidth perspective, these are the pictures. This is the previous generation. Yep.
So let's go back to the bandwidth one really quick. So what we ended up having in the bandwidth one is HDX did a good job. I think you jumped ahead, not back.
Oh, excuse you. Yep. Sorry. Is it back?
We're going forward.
Yeah. Now it's going back.
Okay.
Yeah, here we are.
What we ended up having as a result here is you notice the HDX 5.5 is sending as much data as it can through the 6 meg pipe because it's client-side streaming that video content and playing it back. The View one, it's rendering it on the host side system and compressing it and optimizing and that kind of stuff. So they actually have a better bandwidth profile, and generally speaking, it was in some cases a better user experience. Quest EOP is also doing MMR redirection of the video content and playing it back client side. And Blaze is doing a host-side rendering of this, and you didn't see that video result, but it stutters a little bit in the video playback near the end. Here was the thing I wanted to bring up earlier that I talked about, the impact of host-side versus client-side rendering. The host-side VMs we use in all of our tests are 4 gigabytes of RAM and 2 vCPUs for every single protocol. They get the exact same hardware specs. So when we run this through XenDesktop, because they're doing client-side rendering, you have an initial host-side spike of CPU while it's setting up the streaming of the content down to the client, and then you see almost no CPU happening on the host side because that video is being redirected to the client where it's playing back there. Now, if we had a client-side CPU map, you would see a bump on the client that corresponds to the lack of the bump on the host side. In the case of View, you've got about 10%, maybe as high as 15%, with that spike up to 30% of 2 virtual CPUs, because all that HD rendering is happening on the host side machine. And then here on EOP or Quest, they do client-side MMR, but they're a little less optimized than how Citrix is for their MMR redirection. So they still do have some host-side impact, but it's still not as high as what VMware View is doing. And Blaze did a host-side render here, but again, after they got about half the way through, the Blaze protocol somewhat kind of blocked up with that video, and then the host-side CPU dropped.
Now we're coming to that, to the comparison
yes.
of.
So we talked about all these different tests that we did in the past. We did WordPad and PDF and some very basic applications. Here's the key thing. This is a WordPad script that's running on the host over a 2 megabit connection with 50 milliseconds. So we did two scenarios, 50 milliseconds and 200 milliseconds. So fairly extreme WAN, transcontinental, and then sort of domestic WAN. And so the interesting thing here is that from a protocol perspective, the bandwidth required for these is not a huge difference. You notice that HDX between 5.0 and 5.5, pretty much the same, about 150 to 175 kilobits to scroll through a WordPad document. Here on View 4.6, they were using the lossless mechanism, and so they had a much higher bandwidth profile, averaging about 400 kilobits per second. And in the View 5, when we have the ability to turn off build to lossless, and we've got a more compressed or lossy algorithm, we notice that we have a 68% bandwidth reduction. And the reason why we did these tests is because when VMware announced that they were going to release View 5.0, they released these white papers and marketing guides where they said up to 75% bandwidth reduction. Now, that's true. In some cases, it's up to 75%. But we wanted to test independently, how does it really break down between these different types of content? So that's what we did here. So 68%, that's pretty good.
That's pretty good. That's amazing.
Now we looked at scrolling around a PDF document. Same thing, 72% bandwidth reduction. And what you'll notice too is that these guys are now pretty much on par, or in some cases even lower than the bandwidth profile of HDX. And I don't think enough people are giving credit to VMware how much improvements they made in PC over IP, or really as Teradici, that they are now literally on par with Citrix with a lot of these tests. They're meeting the same bandwidth scenarios that HDX was doing,
yep.
And that's impressive.
And in the past, as you can see, that was not the case. And now they are head-to-head.
So here's a standard def WMV video file playing, and so because we're doing some host-side rendering, we've got some improved bandwidth there, and we have 12% bandwidth reduction. So when we do SD video through WMV, by the way, VMware does not do multimedia redirection on Windows 7, they only do it on XP, so it's host-side rendered in both cases. If it was XP, it would be different, but on Windows 7, they do it all host-side. But we're only getting a 12% bandwidth reduction when we do standard def Windows Media content. So that up to 75 doesn't apply here.
Yeah. Flash, HD video.
Okay, no savings in the case that we went through View 5. Absolutely no savings of bandwidth. WMV HD. This one kind of perplexed me because we actually did get a 20% savings of bandwidth, which I'm not quite sure
how did they do that?
Didn't really have much of a savings, but somehow the HD one had 20%.
I started seeing the same effects when I did the RemoteFX testing, and it appears to me that it comes together with the, sending back results from the client to the server, telling them how many packets it received and how good they are. So it's about the handshake. And if the handshake is optimized, obviously you get more data across the wire, even if you're using the same bandwidth. Yeah. That's really interesting to see. The Flash game?
So Flash game, this one's interesting for two reasons. One, because in HDX 5.0 or ZenDesktop 5.0, Citrix had multimedia or flash redirection. But the flash redirection would stop functioning in about 30 milliseconds. It would fall back to host-side rendering. With HDX ZenDesktop 5.5, they released their second generation flash, which now works up to 200 to 300 milliseconds for client-side flash redirection. And now you notice the bandwidth profile difference while this flash game is running. You know, once the game's loaded, there's really nothing going back and forth other than some basic movements and clicking and that kind of stuff. So the bandwidth profile in ZenDesktop 5 was quite high for that flash game. With 5.5, it's almost non-existent. Now look at VMware View, and it's quite interesting too here because with PC over IP, they have a 57% savings. So that flash game, even though they're not doing client-side rendering, because of the improvements on PC over IP, it's still substantially better than it was under View 4.6.
Good.
So phase 2 summary. You want to?
No, just continue.
Okay, so
you're just in the flow.
So RDP, we still say really falling behind. And this should be no surprise to anyone who's used RDP over the WAN. It's not a good experience. Microsoft knows that. That's why they acquired Callista. That's why RemoteFX is being developed and enhanced. And I truly believe RemoteFX in Server 2012 and Windows 8 is going to be a game changer for Microsoft. Yeah. They're really fixing the protocol over the WAN. It's going to be very good. HDX is generally speaking outstanding. The challenge you have with HDX is depends on what kind of client and host, what kind of policy tweaks you make, and And so Citrix is continually doing a better job of what they call smart rendering, trying to examine the network conditions and adapt the protocol. Sometimes they make the wrong choices, like in the case of that multimedia redirection we showed earlier. PC over IP, I would not have said extremely good back in the Vue 4.6 time. In fact, I said, I think we called it like trying to keep up with HDX or kind of falling behind it, whatever. But now it is actually extremely good. In some cases, even better than HDX, which I think is amazing.
Yeah.
And EOP, almost as good as HDX. The one thing that EOP has that's outstanding is their flash redirection works quite well. Very nice if you have client-side flash you need to work with. Ericon Blaze works incredibly good for certain tests. If you're doing the simple knowledge worker kind of stuff, basic Word, Excel, PowerPoint, these kinds of things, Blaze works outstanding. Certain of the multimedia tests, Blaze really struggles compared to some of the other protocols that are more advanced in those areas. And then we're
yeah, that's the hardware accelerated stuff. Yeah.
So
yeah, we have some critical factors still for these protocols. That's what we found out with phase 2, that bandwidth is required. So if you have less than 2 megabit per second, well, things are hard for the user.
How many people have heard the old myth of 56 kilobit for RDP and 20 kilobits per second for ICA?
Forget about that.
That's not true. You saw some of our graphs.
The truth is the protocols, these protocols, they take all they can get. So if you give them 100 megabit network, sometimes the RDP is going to take like 60 or 70 megabit per user to get a good experience. If you start reducing it, be very careful, not only looking at the bandwidth, but also at latency. At 50 milliseconds, typically things get tougher. And you should also make sure that you don't have too much packet loss. We tested with 0.01% packet loss. And we did some tests with 1%. And things are not looking good if you have that many packets that get lost on the network.
And the reason we did 0.01% is most customers that I work with are MPLS networks. And with MPLS, it's quite common to have very, very small amounts of packet loss. So 0.01 is quite normal.
Do you
Dan.
see any difference with regard to packet loss between protocols that are TCP-based or protocols that are UDP-based?
Yes, absolutely. So TCP-based protocols have a much more difficult time at recuperating from packet loss situations versus UDP. So today, as it exists, PC over IP is a UDP-based protocol, and so they do quite well in most circumstances when there is a regular packet loss. Most of the TCP protocols end up you have retransmissions, and sometimes it's difficult to recover from that. However, many of the protocols like HDX are offering certain types of content like audio streams to go over UDP, so that at least the audio stream is received and processed properly, even if the video stream lags behind. So a lot of the protocol vendors are moving that way. And RemoteFX now, moving forward, is UDP and TCP based, but a lot of the content is coming down via UDP now.
More question?
Since you tested in real life network?
Oh, now it's coming. The real.
I just wanted to ask you the packet loss. If you measure the packet loss.
We did not measure the
We did
packet
not.
loss, but we didn't really have tools to do so.
Yeah.
I mean, we did do some basic ping measurements, which is not a really effective means of guaranteeing that the graphics packets are being received. But we were seeing some in the neighborhood of about 0.5 to 1% on the mobile network. So it really wasn't as bad as I expected it to be. So it was quite good.
Okay, now let's talk about the mobile devices. You didn't bring them with you this time.
I did not bring them with me, but Benny and I were talking about what we were going to do in the next phase of this project. And I kind of said, well, a lot of my clients are talking to me about mobility and iPads and Android tablets and how do we enable our users to be more productive when they're on the road. And so I told Benny, I said, I think we should do like something around mobility. So I was discussing this with my wife, and I said, I got a great idea for the next phase of Benny and I's project. I'm going to go out and buy like a whole bunch of consumer electronics devices, like a couple $1,000s worth, and then we're going to do these results and we're going to give the results away for free. And she said, that's a great idea. Well, wait, no, that's not a good idea. Are you nuts?
I mean, I was buying this device, and Shawn was buying the devices that he was using for the tests, and yeah, our local government, they accepted that because they knew it's for work, and so that was a good story about that.
So I have all these devices in my lab. So we bought an Asus Transformer Prime, an iPad 3.
Isn't that great? Buying toys?
700 piece plate, Samsung Chromebook, and a BlackBerry Playbook. Do you have the? Where we cross out what we're not using?
Yeah, that's a Samsung. That's the Asus. tablet.
No,
Or
I'm saying, do you have what,
oh, yeah.
what we skipped over? So these two devices we're not going to be showing you, primarily for two reasons. One, because the BlackBerry Playbook App Store was having some severe difficulties. I was not able to download some of the clients, and I spent 2 hours on the phone with RIM, and they kept telling me it was my wireless network, and I told them I tried it on 4 different networks. I have lots of networks in my house, and none of them are working. So I said, it's your problem, and then I ran out of time, and I said, okay, I don't show your device. That's fine. And then the Chromebook, you know, Chromebook
try to be polite.
It's a great paperweight. Don't get me wrong. It fits certain use cases. The reason why we kind of, I'm being nice. The reason why we sort of excluded these devices, we talk a lot about remoting protocols.
Somebody's using it. Come on.
We talk about remoting protocols a lot. We talk about remoting protocols. We're talking about things like ICA or HDX, RDP, PCoIP, EOP, Blaze, whatever. And these things exist on these platforms in native implementations for a lot of these vendors. However, when you go to Chromebook and BlackBerry Playbook, it's basically, HDX receiver maybe, which might include some of the HDX features, but not all of them. And then it's RDP and everything else that's out there. I mean, obviously, Ericom has Access Now, which is a great solution, but it's an HTML5 sort of proxy or wrapper around RDP. So it doesn't quite fit into what we're trying to do of comparing these protocol enhancements, because it is just RDP. So
yeah, but you remember, we had this conversation last night where I said we really need a good HTML5 client to do these tests on all these devices, and we're really looking forward to do these tests.
But we
to be very clear.
Extending, probably in phase 4, pure-blown HTML5 across all the protocols. And I'm hoping that by that point in time, VMware has done something with App Blast, and we can get a chance to see how that fits into all of this as well, because it's in some ways sort of like in concept. So what we are covering is these devices over here on this side, and we're covering them for all 5 protocols unless the particular vendor didn't put a native implementation of that protocol. So in this case with iOS, EOP is actually RDP. It's not EOP, so we exclude that from the results. And in most cases, we try to match the same resolution between tests. We won't compare this resolution to that resolution to that resolution, but we'll compare within a singular device the 5 protocols. So we always try to have the exact same client-side resolution. The only exception to that is PC/IP on the iPad doesn't do display mirroring and outputs a different resolution that we can't match to the host-side resolution. So that's a little different. But generally speaking, we try to make them the same through all the tests.
Okay. And then we're gonna compare them again, doing the split screen stuff again. Okay, trying to finish.
Is there a question or no? Okay.
Let's go back to that one. Some water? Yeah, we still have like half hour.
Cool. 20 minutes at least.
Okay.
Let's jump into WordPad scrolling.
The WordPad scrolling?
This first device is the Samsung 700T Slate. It's actually a really nice device. It has a Core i5 processor, so lots of client-side processing power. And we're going to run HDX versus PC/IP versus RDP versus EOP. And what you see over a 3G network is, despite the fact this is only 3G, it works quite well for simple applications like WordPad. You really can't discern a big user experience difference between these two. You might notice that PC/IP and HDX seem a little bit less laggy, but even RDP does a fairly decent job with looking at the WordPad content.
What's next? PDF scrolling? What do you want?
We'll skip PDF. It's actually quite similar. Let's go to QuickTime.
QuickTime? Oh, wow. Is that QuickTime? Let's see. Oh, yeah, it's QuickTime.
So here we have a 480p QuickTime video. It's Body with a Chance of Meatballs. We've been using it for like 3 years now.
Oh, yeah.
Now, keep in mind, Citrix has no client-side rendering for QuickTime, so all of these will be doing host-side rendering. Nobody has client-side rendering. And what you notice is that the build the lossless disabled view and the HDX both do a pretty decent job. The Quest EOP, better than RDP, but struggling a little bit. RDP, completely unusable over the 3G network. You're seeing huge gaps in between.
You said you wanted to be polite.
What?
You said you wanted to be polite.
I'm being polite.
Completely useless is polite? What do you want?
Let's jump into Flash. Flash.
When those videos drift off at very different times, they're running at different rates.
No.
Frame rates are different and the deliveries are different.
Not really. The thing is that we're starting them at exactly the same time. Sometimes it takes longer to load stuff and to cache stuff, And so they're a little bit out of sync.
Yeah, they are started at the exact same moment. So there could be a 1/10 of a second gap if you know we didn't hit them at the exact same moment. But generally speaking, the tests that are run are scripted through AutoIt.
Yeah.
So as they run through the operations of a file open.
So it looked like the videos were playing at different speeds.
No, they are not.
No, so here's how it gets different. Keep in mind, we're scripting the entire loop of opening the file type association or launching the file, and then we're altering how the application interacts with that file. So we have to perform a file open key stuff, then the dialog pops up, we key stuff in the path of the file that we're opening, and so if the protocol does a poorer job at painting those dialogues, it may start the video a 1/4 of a second later than what something else did. But that's an important thing to consider because it's slower at doing that loop.
We have scenarios.
Still is the videos ran at different speeds.
Yes.
Well, the video itself, the frame rate of the video is exactly the same because what we do is we connect it to the
Well, you're saying the user perception.
The user perception.
Are playing. So when the video starts to when the video ends is different under different protocols.
You're talking about the video inside, and you're not talking about our videos that we recorded.
Correct.
Correct. Absolutely correct.
Right.
Absolutely
So
correct.
my question
Yes.
is what happens to the sound?
So that's one thing we haven't covered in our presentation yet is the audio-visual sync.
Yep.
And the reason why we haven't covered that yet is because it's impossible for us to do direct comparisons, 4-up comparisons between these things. You can only hear and see one at one time. Phase 4, possibly. What we may
I'm working on a setup for that because it's not simple. Because we are feeding the video output, the VGA output or DVI output into this device. This device doesn't have an audio input. Now, if you are using the USB signal to record the video and you have the audio signal coming through another way, they are not in sync by definition because USB has some latency. So we have to find a way to make sure that both the audio signal and the video signal that we record are in sync. So if then the result by remoting a video with audio is out of sync, that we can record it appropriately.
Yeah,
and this is a real challenge setting up such a test environment. I'm really thinking about it, and it's another interesting conversation I have with my wife, what I'm building in my lab around the video equipment that I have. Because sometimes people come into my lab now and say, wow, this looks like a video recording place. What kind of videos are you recording down there in the basement? I said, well, what do you think I'm doing here? Well.
So the 2 challenges we have around AV sync, one of them is how do we capture without any skew? And what we'll probably end up doing is there's a higher end Epiphin device that's about $3,000 that does audio-visual sampling at the same time and muxes them together with no skew. So we'll probably end up having to buy 2 of those devices, which is added expense to what we've already purchased for all of this. The other scenario
is... You said we don't talk about the money.
No. The other scenario is we have to make sure we have legitimate tests that you can identify skew appropriately. So what we're probably going to do is there is some stuff used in the AV industry where you can identify sound skew by sort of like a tick-tock that has the differential skew. When the pendulum sort of strikes one side, you can see how far behind the sound is of the video, but that's also hard to convey. So we're trying to address that, but it's going to be hard to come up with good test cases.
Now let's do whack-a-mole. Whack-a-mole.
So here we have flash content.
Here, whack-a-mole.
HDX has client-side rendering, so you see a very, very good user experience. PCoIP also does quite well, even over 3G with this one. RDP, you see the flickering of the repainting delays, but it still actually performs quite well. And in EOP on the Win 7 tablet also does a good job. So even Flash over 3G, as long as we're using a Windows 7 client device, works pretty well across all of these providers.
Do you see how fast he is?
Well, see, what was easier with this one is because it's tablets, I don't have to position a mouse pointer, so I can just tap everywhere, so I was much quicker.
So this is what tablets are good for.
Yes.
All right. Okay, now what we do is the Silverlight.
Silverlight photo gallery.
You don't want it?
No, yes.
Yes, yes. You want that?
So this is a Silverlight photo gallery that's actually pulling in bitmap images. And so the bitmap images, you of course want the sort of Ken Burns effect to be smooth, which HDX does a very good job for. You stuttering there a little bit, and we recorded this one multiple times. We're not quite sure. We also had some repainting issues that happened there, which is very, very odd. RDP, you can see the typical painting by blocks That's very common with RDP. And here we have EOP that does a much better job, still not quite as fluid as what HDX is doing.
Okay. Now doing the same thing on 4G.
We wanted to see on 4G to see if this was truly just a bandwidth limitation issue. If we increase the bandwidth going to 4G, is that going to change the results? And what you end up finding is for the protocols that were having more of a challenge, definitely during the beginning, even RDP is doing a better job. You're not seeing as much of the block painting. And the other protocols are also now doing a much better job. Now keep in mind, going from 3G to 4G means that our downstream speed goes from about 2 to 3 megabits to about 8 to 10 megabits. So we've sort of doubled or tripled our bandwidth capabilities, which means this now will run smoothly for most of them. You do see near the end, though, that RDP starts getting overwhelmed with bandwidth and eventually slows down again.
What can I do with all the bandwidth? Okay.
So those tests are performed in Chicago or?
Yes, so
these are in Chicago.
It's Chicago to Chicago.
These are Chicago tests.
I'm on a
not available in Europe.
Wi-Fi device, and I'm connecting from the mobile device to the carrier network in Chicago, connecting right back through an external separate ISP to come through on the external side. The limitation that I have right now is the upstream bandwidth speed that I have available in my office is a 5 meg upstream, the 16 meg downstream, but 5 meg up. And this is business class connectivity. It's not like some ADSL or something like that where you have no committed guarantees and that kind of stuff. But because we have 5 meg upstream, if we ever try to push content, it would have been like 12 megabits per second. We would be capping ourselves at 5 meg. So down the road, we may try to adjust that by bumping the upstream speed. But almost all of these will work legitimately fine in 5 meg upstream. So that's not going to really affect most of these tests.
Okay, now let's compare the iPad stuff. QuickTime on the iPad with 3G.
So what you might have noticed there on the VMware one is I had to have that little keyboard popping. It's a Bluetooth keyboard, so you have to invoke the keyboard and then hide the keyboard before you start the test.
What RDP client are you using on your iPad?
I'm sorry, I should have said that earlier. The RDP client that we're using is the Wise Pocket Cloud. So Wise Pocket Cloud is used on the iPad. So this is the HDX receiver. We've got all the version numbers documented. That's the official view client. This is Wise Pocket Cloud, and that is the Ericom client, the Access Now, or I should say Blaze. Access to Go, thank you. I was getting stuck in the words. I was like, I know it's Access. So Blaze actually, in this case, does a much better job than what traditional RDP. I mean, the video here is not even started yet, and Blaze has substantially improved the RDP user experience. And you saw the HDX one was pretty decent, PCoIP was pretty decent, but you did notice a pretty severe difference between how this ran on iOS versus how fluid it ran on the Windows 7 endpoint. So you clearly see differences between the user experience when we're going to the iPad.
And now let's do the same on 4G.
So we did have some stuttering a little bit on the 3G, so we're going to do the same thing with increased bandwidth and see if that improves the results. RDP is still struggling a bit. Blaze, again, doing a pretty outstanding job. You see a little bit of screen blocker painting here with Blaze, but it's still a fairly fluid experience. HDX is a good experience, and the view experience is actually quite good. Not a lot of stuttering in the video at all. But RDP, even with the additional bandwidth, is still struggling as it was on 3G. So the increased bandwidth has not helped RDP in this case.
You know, when you're doing the testing on the server side, do you preload them as other systems running at the same time?
Preloading?
Do we do what?
The question is if we preload the stuff.
We had 100 VDIs running.
Yeah.
And you're doing all this graphic stuff on one particular VDI, and the rest are just doing generic stuff.
Oh, so yeah, I should be more clear about that. We don't have any other VMs running on the host machine.
It's only one.
It's a Core i7 white box, 24 gig of RAM, and the same Hitachi 500 gig SATA drive. When the system is booted up, it's the singular Win7 VM with 4 gig and 2 vCPU, and it has all 4 cores of the Core i7 at its disposal, and so there's no contention for resources. So thank you for asking.
Yeah. Flash HD video?
Sure.
On
Flash.
3G? On the
iPad. We
iPad?
don't really have the benefit of the client-side flash rendering for HDX. We have to rely on some server-side rendering. And so what you find here is that both View and HDX do a pretty decent job, but you notice the View one is much more choppy than the HDX one is. RDP, completely unusable, and Blaze in this case, better than RDP, but not as smooth as HDX is or PCoIP.
Okay, let's do the same on 4G.
We've got more
That's
bandwidth at our disposal, so we
Yep.
expect the results to be slightly better than most of these protocols. And again, with the RDP result, we still end up finding out, even with increased bandwidth, it's better. You're not seeing as much block-by-block painting, but it's still stuttering way too much. Blaze providing a decent user experience. Again, HDX doing okay, and PCoIP doing okay. But still, these are not quite the experience that a user would want to use this flash video.
Is there any chance that your RDP experience is related to the choice of RDP client?
Yes,
yes,
it absolutely is.
Yes.
So Wise Pocket Cloud, it does not offer us very much options for tuning. The reason why we use Wise Pocket Cloud is it was one that was available for both Android and iOS, and it was easy for us to use, fairly consistent product between those devices.
Now we're doing whack-a-mole again on 3G.
Yes. So RDP, not even getting started, and when it does, it's so unusable that you really can't see it react. Blaze doing a decent job, but you can definitely see some stuttering there on the iOS device. HDX and PCoIP both doing a pretty decent job, but again, on the iPad, this is not anywhere near what the user experience is on the Windows 7 tablet. Whether you're doing hybrid rendering or host-side rendering, it's still a much poorer user experience.
Doing the same on 4G.
Now on 4G, we do the same gameplay. What we end up finding out is that the user experience is a little bit better on the HDX. It's a bit smoother than it was on 3G. Notice here with the PCoIP, you can definitely see a delay between when the mouse pointer clicks and when the system actually reacts and tries to smash the little whack-a-mole. Blaze providing a decent experience, RDP still completely unusable.
So,
just a question, why is the PCoIP in all these videos like smaller?
Oh, so that was the PCoIP, the view client, doesn't do display mirroring, so it outputs a different resolution on the DVI cable that we output from the iPad versus what the iPad's actually running. It doesn't do the mirrored display. It outputs a completely separate resolution. So it is not completely fair for us to say these are all the same, but we always tried to make the resolution 1024 by 768, except in the case of View, where they didn't output 1024 by 768. They only output a landscape, I think it's like 1280 by 720 resolution. So we tried to match them whenever we could, but in this case we could not.
but look at the results that he is getting on RDP without seeing what's going on.
Yeah.
That's amazing.
It does a great job, it's just you don't actually see any of it.
Okay, let's go to the Asus Transformer on Android and do the flash demo there on 3G. No, going back. That was not the one. Flash demo.
So here we have RDP7 with Wise Pocket Cloud. We have the EOP on Android, and we have the PCoIP View client and the Citrix receiver on the Android tablet. These are all the same resolution, but you see the client's a little different because you got that bar on the bottom for the View client. But here, RDP, again, painting the screen. It's not a fluid experience. Blaze, which has some improvements above RDP, makes this pretty much usable.
That's
Sorry,
EOP.
Has improvements over traditional RDP, and it's a decent user experience. And then the HDX and the PCoIP, again, this is pretty fluid user experience. It's not bad. Yes?
To that point, I mean, from what you've seen there, the guy over there was right. Your impression is that they're running at different speeds. But if you took one frame, a start frame for each one, and then ran that video from that frame.
Yeah, we've talked about trying to come up with a sync for the beginning of the actual content. We have not done that yet. But yeah,
but that's also the feeling that we get that the frame rate is,
The only reason why we didn't do that is we wanted to illustrate that when you perform this scripted open of the file, that the slowness of the protocol delays that whole process. So that's the true user experience, is they can't even get the file open yet because the dialogues aren't painting. But I agree with you. We should come up with a way to sync something that flickers on the screen that we can then key the video file so they all start at the exact same time. So thank you. Sure. That's good.
Oh, yeah. So that was the stuff on the 3G. You want to see the user, the whack-a-mole again on the 3G?
No, we can do the 4G now.
The 4G?
So again, more bandwidth available, but this is also going to be limited by where you have 4G availability, which in Europe is quite constrained right now. Again, RDP, still quite a useless experience, but it's better. I mean, it does, you click a bit faster. PCoIP and HDX are both a good experience here, but you can still see, again, with View, a slight delay between where the mouse pointer is positioned and when it actually reacts, and you don't see that with HDX. And in this case, EOP on the Android actually doing quite poor in this circumstance.
And it's clear that we're really looking forward to see the release candidate of Server 2012 with RemoteFX. And if we find the clients that are able to, well, interpret RemoteFX, we want to compare all these existing results to RemoteFX then on these different devices.
So I think we have like 10 more minutes or 5 more minutes. So let's do the last video with the latency hint.
Yep. The latency hint. Can you just share the story behind the latency hint with
Benny
people?
and I did this, I think it was phase 1.
Yep.
And we're showing the RDP experience. Nellie Porter, who led the RDS team at Microsoft, came up to us and asked whether or not we had tuned the latency hint for RDP. And Benny and I both looked at each other like, the what? The latency hint? What are you talking about? She's like, oh yeah, we did a bunch of work in the last release of RDP where we now adapt to latency. It was like, did you tell anyone you guys did this work? I mean, that would be kind of unfortunate.
Here it is.
So here's what it is. So you see these two settings here when you go in the Experience tab. One that says satellite 2 to 16 megabit with high latency, and WAN 10 megabit or higher with high latency. The unfortunate part about this is most people that are working from home are going to look at this and say, oh, I have high-speed broadband, 2 to 10 megabits per second. That's my selection I want to choose. But the reality is, either one of these ones with high latency will make a better user experience on practically any WAN connection that you put this against. It makes a better user experience. So I don't know why this is not just a default, because nobody knows about it.
Yeah, I will dig into that during my session tomorrow, because it's an interesting lessons that you can learn from the difference between the two.
So this is the same 4G connection over the Win 7 Samsung, where we have the ability to tweak this user experience setting. We don't have that on all the protocols. But notice how the video, again, the keying of when the video starts is a little bit off, but when the video starts on this one,
there's a fundamental difference between the two.
Here we have the satellite connection, and here we have the one with the broadband selection. So you noticed how this video not only started playing sooner, but it is also smoother, whereas this one is stuttering and block-by-block painting. This is the same endpoint device, the same host, the same WAN connection. All we did is said, we're connected over satellite versus broadband, and you get a much better user experience.
And Microsoft called it the latency hint. So it's not that you can enforce this setting. It's just the client says, well, I believe I am on a high latency network, so please, dear Mr. Server, can you adapt accordingly? And the server says, well, let me think about it. Maybe I do, maybe I don't. So if they do, this is the result that you get. Oh, Nadim. So he's the one. Nadim is on the RDS team in Redmond, so he should know about these things.
Yeah.
Can I bring you a microphone?
I'll try to speak up. So the dialogue that Benny showed is actually the Windows 8 version. And one of,
Yeah, it's a Windows 8 tablet.
Yeah, actually, is it on?
No.
Okay. Can you guys hear me?
Yeah.
So in the 7 version, you have to choose the actual latency, and exactly what you said is right. It is a hint. It's advisory to the server. In 8, actually, the default, the last row in that is detect automatically.
Yeah,
And
that's
so
new.
Your users will not even have to go there. The system will automatically sense what is the right latency and apply the right tuning. And actually, a lot more stuff goes on behind the scenes. But in essence, you'll get much more the better experience than the worst. And hopefully tomorrow's session we can expand on all that.
So, but this was an interesting experience for us when Nelly told us, hey, didn't you use the latency hint? And we said, the latency what? and if we didn't know, we thought nobody out there in the world knows. OK, almost nobody. So what was the feedback that you received after well, did anybody use it in the field? Did you get the feedback?
I mean, I guess it's a question for the room here. If people truly are aware of it.
How many people know about this latency hint and you're using it?
Whoa,
Hands.
whoa. That was different about a year ago.
We enable it in the RDP EFD client.
Yeah.
OK. All right. Final slide. No, you.
Okay, so
Your
quick
show.
summary. As we showed you guys before, both from a bandwidth profile perspective and from user experience, PCoIP has closed the gap with HDX, and they are now pretty much on par from a user experience perspective and bandwidth profile. Simple office productivity apps, WordPad, Office, these types of things work very well over a 3G connection regardless of protocol. Even RDP does an OK job on 3G for very simple stuff. Richer media only working well on HDX and PC over IP and these enhanced protocols. Also, Windows Client OS, regardless of what protocol, seems to offer the greatest user experience versus iOS and Android, these things. And 4G speeds make most of the media remoting somewhat acceptable. It still doesn't do a great job for HD media content and that kind of stuff, but for standard definition videos, YouTube, these kinds of things, 4G networks really make this tolerable on and more advanced protocols. And then the last thing, user experience rules. And as much as everyone says these protocols are the same, there's no differences, you clearly see there's very big challenges when it comes to these mobile devices over these wireless wide area network connections.
And that makes it an interesting twist for all those who say, hey, I'm just going to give you an iPad and you can use the Windows apps. Not that you cannot interact with the application so easily. You were seeing how I was struggling with some of the Windows apps because the buttons are just too small and I'm using the stylus in order really to start certain functionalities. Now, if you're using an iPad, this is not going to work. And this degrades the user experience dramatically. And not only the refresh rate, but also interacting with that sort of applications. So I do not believe that remoting the desktop, the full desktop, is going to be the future. So we have to be smarter with the applications that we provide to those mobile devices. So I think this is going to be the future.
As I say, nobody wants a Windows 7 desktop on an iPad.
Not really.
It's just collateral damage to get the data in the apps. That's what people really want.
OK, that's it. Now we're open for questions. For
1 minute.
Another minute.
Do you have any thoughts on WAN optimizers or
WAN optimizers.
Yes. So some of the vendors that are out there do a better job than others do. Riverbed, Ryos is very, very strong with the remoting protocols. They do a pretty decent job. So my advice, if you're going to get some kind of WAN optimization controller, it's Riverbed would be one of your best bets. That being said, Riverbed doesn't optimize ICA as well as branch repeater does. And ultimately down the road, Cisco WAS will probably do a very good job with HDX as well because they have the cross-licensing deal now where they have the ICA protocol specs. So I think down the road, Cisco WAS will be a good offering. Today, it doesn't really do anything for the remoting protocols. But today, Riverbed, in my mind, again, my opinion, Riverbed is the best WAN acceleration device on the market today.
OK, for more information, please just come to the session tomorrow. Shawn will be there. It's the last session tomorrow. It's also in this room about the RemoteFX stuff. Nadim will be there, so this is going to be very interesting. I hope both of you are going to sit in the first row, and I give you a microphone. So
we'll heckle you.
Oh, huh?
We'll heckle you.
OK.
Thank you.
OK, thank you very much.